Hello folks, we come to the part 2 video of this miscellaneous exercise, and let's take this problem number 3 and let's see what it says. It says that f of x is given as x squared minus 3x plus 2. You have to find f of x. Nothing great, we have been doing this for quite some time. So let's find out what is f of x or f of x. So therefore f of x, let's find. First we already know the f of x. It is f of x squared minus 3x plus 2. Now when we apply f, the first term is your bracket term square. So bracket term square minus 3 times the bracket term plus 2. It is about elaborating this and finding out what the answer is like. So let's check what comes up. X squared minus 3x plus 2 the whole square. So it will come to x raised to 4 plus 9x squared plus 4 minus 6x cube minus 12x plus 4x squared. Please mind my expansion over here. This is what I have expanded. Now let's expand this. Minus 3x squared plus 9x minus 6 plus 2. Okay, let's club the terms. X raised to 4. Cube terms, there's only one cube term, minus 6x cube. Square terms, you have this, and you have this. So 9 plus 4, 13, minus 3, 10x squared. 10x squared. And then the x terms, this is there, minus 3x. And the constant term, 4 plus 2, 6, can cut with the 6. So that way it will get off. I hope you have covered. I'm just checking if all the terms are covered or not. Yeah, and it's worth cross-checking the answer. What is it? X raised to 4 minus 6x cube plus 10x squared minus 3x. Yes, so that's it. That's nothing great, just routine. Okay, next our question is a function f that is defined from R to open interval minus 1, 1 such that f of x is x by 1 plus modulus of x. You have to show that is 1 to 1. And on to, now if it is x by 1 plus x, not a big deal, we can just do it, but because it is modulus of x, it will call out from several cases. You have to do it in several cases because x can take any value. It can be positive, it can be negative. On the basis of that, you will have to take different cases and you have to solve that and get the answer. So we'll do it for 1 to 1. We will have so many cases. There are following cases. Right? Case 1. We will deal with x1, x2. We know either that x1 is positive and x2 is positive. Then case 2 is x1 is negative, x2 is negative. These are easier cases. Case 3 is any one is positive and the other one is negative. Like we have to take a case 4 where we can take x2 less than 0, x1 less than 0 and x2 greater than 0, but it's okay. The meaning is that one is positive and one is negative. We have to consider all these cases when both are same signs and when they are of different signs. So we have taken all the cases, and in all the cases we'll have to show that it's 1 to 1 and 1 to 1. And in on to, of course, we can take positive and negative and then that way. So let's see now how this goes. So we'll take case by case. So case 1. Let f of x1 be equal to f of x2. Now case 1 both are positive, so it is like x1 by 1 plus x1, x2 by 1 plus x2. Why? Because if x1 is positive, modulus of x1 is x1, and if x2 is positive, modulus of x2 is x2. So that way it is like this, or maybe you can write the definition and next step you can write the wish. So then we can have it like cross multiplied, x1 times 1 cross 2 rather. x2 times 1 plus x1. So when we open it is x1 plus x1 x2, and this is x2 plus x2 x1. x1 becomes equal to x2. So starting with f of x1, we are getting x1 equal to f of x1 equal to f of x2. We have got x1 equal to x2. So f is 1 to 1 in this case. right? Now let us take the next case where we are taking both negatives. So case 2, let f of x1 be equal to f of x2. So that will become x1 by for avoiding confusion, modulus of x1 x2 by 1 plus modulus of x2. Because it's negative, it will be minus x1 minus x2. Then cross over. x1 times 1 minus x2, x2 times, opening up, so you have this cancelled, you are getting x1 to be equal to x2. Starting with f of x1 equal to f of x2, you are getting x1 equal to x2, so f is 1 to 1. In this case also. Now case 3, where 1 is positive, let f of x1 be equal to f of x2. So x1 by modulus of x1, x2 by modulus of x2. Now x1 is positive, so therefore it will be 1 plus x1. x2 is negative, so it will be 1 minus x2, because that's how we define a negative function. Modulus of a negative function will be minus x2 and a positive function will be as it is. So that way, then we'll have crossover. Sorry. x2 plus, let's have this here, x1 minus x2 is equal to x1 x2 plus x1 x2, so that is 2x1 x2. Okay, now this is your left hand side, this is your right hand side, and let's check now how this is going to work out. Let's look at the left hand side. Here left hand side is, see, this is a positive value, this is a negative value, so when you will have x1 minus of that negative value, it will be in fact turn to be positive, right? x2 is negative means it's something like minus 0.2, or it is something like minus 0.3 or minus 0.4, minus 0.02, something like that. So x1 minus of that minus will make it plus, so it is positive. Okay, and how about the RHS? Let's check. RHS is, now this is positive, this is negative, so when you in turn put the values, you will get LHS as negative. So LHS is positive but RHS is negative. That is not possible in an equation, right? Now why that has come? Because such a case is not existent, so you don't have to take this case. That is why this problem is coming. This is not possible. So this case cannot be considered. Right, then we go for part. Okay, that's all about 1 to 1, and then we will quickly take up on 2 and we'll see how. Now on 2 also, in fact what we will do is we'll first try to understand the function, and then we will try to see how it is. Like, see, the function is going from real to real, and it is like this. You are having terms from minus 1 is not there, so something like minus 0.9 if you want, minus 0.8, minus 0.7, of course, and it's in between value 0, then 0.1 and so on till 0.9. Of course 0.99 till that there is values are there, but then roughly this is how your term is. And here of course you have the whole real numbers. Now they say that you take an element, you should be able to find a pre-image. Now it's easy. What we will do is we will take, for a positive point in the codomain, there is a different pre-image. For a negative point, there is a different pre-image. So we'll take two different cases and then we will try to analyze it. So for 0, it is of course 0. So we will take let y belong to minus 1, 1 such that y is positive. Okay, so we'll try to do that rough work. So it is like y equal to, that's how we do it, x plus x. So it will be y plus yx equal to x. So y will become x minus yx. So it will become x times 1 minus y, x will become y by 1 minus y. So there's a pre-image y by 1 minus y that will be there. Okay, so for example, if you Okay, there exists y by 1 minus y belonging to R such that f of y by 1 minus y. Let's check. Now this is positive, so it will be y by 1 minus y by 1 plus y by 1 minus y. When we equate, this will be 1 minus y by 1 minus y, so y by 1 minus y whole by 1 minus y plus y by 1 minus y, cancel, finally y. Okay, so you know the preimage. For example, suppose if you take like 0.1, suppose if I have taken 0.1, you have to know what is its preimage. Then you just substitute in this 0.1 by 1 minus 0.1, so that is 0.1 by 0.9, so that means 1 by 9. So you take 1 by 9 and put its image, it will be this value 0.1, so that way. So also, and for y belonging to minus 1 1, y less than 0, there exists what? So now that we have to find out, it is x by 1 minus x is equal to y. No? So how do we find it out? Y times 1 minus x, so it is y minus yx, so it will come here, so it is x times 1 plus y equal to y. X is y plus y by 1 plus y, so y by 1 plus y. There exists y by 1 plus y belonging to R such that f of y by 1 plus y. Let's apply the definition. It is y by 1 plus y, now this is a negative value, so it's 1 minus y by 1 plus y. So let's equalize 1 plus y, 1 plus y. So it will be y by 1 plus y, 1 plus y minus y by 1 plus y. So that will come to y. So in both cases we are able to get the preimage. If it's positive also you know the preimage, and if it's a negative also it's preimage. 0 you can include anywhere. Now y equal to 0, the preimage is 0 itself. Okay, so this is how we are able to show that f is 1 to 1 and odd to. So therefore f is odd to. So we have shown that is 1 to 1 and odd. Very intricate, right? So that's all about this video. With more problems, we are coming in the next video. Thank you.